I have really many.
Oh God, yeah. All right. Sweet. All right, so there's a sign-up sheet that's been passed around. I kind of just like brought it in the middle. So if you guys haven't signed up, just make sure you write your name on there. Yeah, it's just like just to keep track of like who's coming, who's not. That type of thing. Usually what happens. Potentially. All right. So do you guys have any specific questions before I just go over some review questions? Probably not. I didn't think so. That's fine. All right. So breakdown of the test. The test is all the same, basically like what you guys have already been doing. It's multiple choice, decent section of that. A lot of them are going to be like some problems. We have to do calculations, make sure to bring a calculator, make sure to bring an extra pair of batteries just in case it dies on you, because that does happen sometimes. And on the previous test 1 and 2, have you guys actually had pre-response questions? No. Okay. Zion specifically emailed me giving me a few of some word problems that you guys might have to be doing. He said they might be on the test. He's very vague about it, but I mean that's what all teachers do. So I'm gonna try to give you guys some conceptual stuff, and hopefully you guys will understand that. And then Nick is here. He's from the ARC. He's like one of the ARC tutors for chemistry, so he's gonna be here. And he could answer your questions as well. So he might like chime in a few times. Hopefully more than a few times. All right. So, is there any subject that some of you guys are like really struggling on, or you feel like majority of people are struggling on? Because I want to like all of them. I guess it's a good question. It's a good answer. How about let's just go straight into. Let's see if I can find an example problem for you guys. So make sure you guys have. Okay. You guys are definitely going to see one of these type of problems. You guys can't read my handwriting, I really apologize. I probably should rewrite hydrogen. Vegas, that's really smart. We got a few seats here, one there. Hey, I can move myself. Got a few seats left.
The first ARC session I've been to that actually has
like
A lot of people.
for a test. Yes.
People are shitting us.
All right. So this answer should be pretty simple. Yeah, what's up?
Like, should we like figure out like the wavelength of the UV ray? One.
You can, but there's an easier way to just explain it. You just basically this one actually requires you don't even need to use an equation. This one you can just straight up just answer. All right. So what are your possible answers though? Because Bohr's model. Can someone explain to me what Bohr's model looks like? Okay, what's up?
It looks like, well, you have the proton and you have the nucleus in the middle. You just have circles around it. That's
Exactly.
correct.
Exactly. So you have what's up?
I'm moving my desk.
So basically the Bohr's model is what you guys have like the nucleus in the middle, and you guys have these outer shells going around, right? So each shell represents like a level, all right, an energy level. Now this question is saying, according to like Bohr's model specifically, if you have something that starts at 3 and the energy is dropping and then emits a photon, what two values could be true?
N equals 2 and N equals 1.
2 or 1, right? It has to drop in order to actually emit some type of photon. So UV, some of you guys actually might not know this, but did he talk to you guys about the series, the specific series of drops? No, maybe? Yes? I see a yes. So that means I know that he for sure has talked about it. So you have the Lemans series and you have Balmer's series. Do you guys remember those? Does that ring a bell?
Yeah.
Okay. For this one, I'm just going to give it to you guys because it's something that you guys have to memorize. This one would actually, NF, the final, would be 1. Okay? Reason why, usually the higher, you guys understand that the bigger the changes between the energy levels, the higher the frequency of the photon. Yes?
Yeah.
Yes? Good. So basically the answer to this would be dropping down to n equals 1. So your answer would be NF equals 1.
How do you know that though?
Because if it actually, well, according to like the series, Balmer's series says that if it goes from 3 to 2, it's only infrared. So therefore, only other possibility is going down to 1. Yeah.
So he told us not to like memorize the
Yeah.
values.
Well, for this one, if I were taking the test, I would just assume that it was 1 because a energy level drop is not necessarily like the strongest, and UV is pretty strong according to like the frequency, like the wavelength. So
Another way that you can go about it, kind of like dissecting it, is you're pretty familiar with like UV versus IR, you know, like those have been like some big transitions.
Right.
So you can be like, okay, we're at 3, and it's either going to go down to 2 or 1 with respect to our diagram. So you can think about it, well, it's UV are energy, higher frequency, right? More like hits per second, right? So you can think of it like, well, if it's UV, it's going to drop more. So if we have either drop 1 or drop 2, it's going to be dropping 2. So that's another way to think about it.
sweet.
If that helps.
Does anybody have questions on it or still stuff about it? So I want to make sure you guys understand. Yeah.
Okay, I have a question that's kind of not related. Will we be given the same equation sheets that we were given on the quizzes?
Yeah. You guys should be given like all of the the constants of speed of light, Planck's constants, Rydberg's constant, Avogadro's number. You're also going to be given like the light equations. So that should be a huge help. You guys are also offered the change in energy based off of Bohr's model. Remember like the RAH and the initial minus the, or like the inverse of those. Right. Remember those? Okay, good.
Yeah.
So those, yes, all those will be provided for you guys. It's basically all the tests. You'll be provided with those stuff. All right. Besides that, any other questions? No. Okay. All right. So let's move on. Zion likes to do the whole thing where it's like, hey, I'm gonna make you do or solve a problem, but give you sub problems.
Yeah.
He likes to do that, so that's basically what this is going to be doing. So it's going to be
A through G.
Yeah, right, A through G. Okay, so we're going to do. Yeah. Right. For this specific question, if you didn't get the first answer, I'm gonna let you guys know that on the test, it's gonna say like, okay, if you didn't get the answer to the first one, then assume that n final is 2. Okay, so that gives you guys a chance. Like, if you guys can't solve A, then just go straight into B and then solve it with a given value. Yeah, what's up?
Is the given value ever going to be the real value?
No, definitely not.
It's always wrong.
It's always wrong.
If we're only given 2 options.
You could think of it that way.
Exactly.
If you wanted to find a loophole,
I like
yeah.
the way
What's
you
up?
did it.
Wait, sorry, what's up?
If you got the wrong answer, but you thought it was right the first part, you use it for the rest of the problem, can you still get points for that?
Yeah, you should still be able to get points. That's how majority of his tests work, is exactly what you just said. If you answer the first one wrong and you think that's right and you use it continuously, but the thing is you have to use it continuously correct. That make sense? Yeah. So to answer your question, yes. You still get partial credit for everything else if you just mess up the first one. All right. So, anybody figure this out?
The change of energy of an electron.
Of the electron.
Isn't it negative R over n squared? That's the wrong one.
Negative R over n squared.
Yeah.
That is not the right one. Because we're using the value from above. You know that NF is 1, right? So we're trying to figure out what they mean by electron is essentially the photon, right?
Oh, we still use that same equation, the Rydberg equation.
Yeah, that.
Isn't it change in energy equals R parentheses 1 over n1 squared minus
Wait, and what?
n initial squared minus 1 over n final squared.
Yes, that is the equation. You will either see it in this form. Just keep in mind, don't let this trip you guys up. This can also be written as negative RH and then 1 over n final squared minus 1 over n initial squared. All right. So make sure that you guys understand that those two are the exact same thing. It's just the negative sign and the flipping. It's essentially just taking out a -1 or -1. All right.
Now, I assume that the change in external energy is in joules.
Do you? Yes. No. Maybe.
Yeah.
Yeah. Alright, just gonna wait till once I see the majority of people keep looking up. What's up?
How many sig figs would you want on this question?
Ooh, this question. That's a very good question. Well, definitely not just one.
No.
Definitely not just one.
How do you find R? Is R a constant? Yeah, R is a constant.
R is a constant. If you guys don't know what R is, if that's what's stopping you guys, RH.
Equal into 187.
So, sweet. Oh, geez. Just one and two. Oh, for those of you that might have came in late, there's a sign-up sheet. I don't know where it is right now. No idea. Sweet. Awesome. Yeah. All right. Anybody saw this, and if you have, care to explain? Besides it.
Is it 1.743 times 10 to the negative 17?
Say it again?
0.743 times 10 to the negative 17.
Close, kind of. Close, kind of. Not exactly. What's up?
Negative 1.94 times 10 to the negative 19.
Yes, it is. How did you come up with that answer?
So I used the second one.
Okay.
Because I used the final one initially. So we just plug in Rydberg's constant. So negative 2.179 times 10 to the negative 18.
Jesus. 7, 9 times 10 to the negative 18. Yep.
Times in parentheses 1 over 1 squared minus 1 over 3 squared.
There you go. Yeah. Pretty simple. Yes.
What was the answer?
My bad. Yes. So basically, from here, you just plug in chug, and then you get your answer, right? Awesome. So make sure that sometimes it might just boil down to arithmetic. So make sure you guys are double checking your answers. All right. Make sure you're double checking your answers.
Wait, would the answer have 4 sig figs because we're using it to the 4 with 4 values?
Yeah, it can be to the 4. I just decided to use 4. But
Okay.
to be honest, when you're dealing with constants, he's going to give you like 8 sig figs, and I highly doubt you should put 8 sig
They
figs.
typically like 4 or 3.
Yeah. Choose between 4 or 3 if you're unsure.
And always check the sign of what you get afterwards too, which makes sense why we get a negative value. Yeah? Can anybody tell me why we get a negative value?
Is it emitting?
Exactly. Yeah, we're just emitting. We're
Because
not
you're
absorbing.
losing energy. Because you're going from a higher to a lower stuff level. Cool? Awesome. Alright, and as you guys might have guessed, we go to C. And we're going to do and then same thing goes for this one. If you guys didn't figure out B, he's going to give you a value to use. What's up?
For this problem, don't we use the equation change in energy equals H times U? I forgot.
Yeah.
Yes. And H, is it H 6.626 times 10 to the negative 34?
Yes. Let me write that down.
And then the change in energy is what we had in the last problem. So we're going to do some dividing.
How about you come up with an answer, and then I'll say if it's right or wrong.
What was the change of energy for the last problem?
You should have written it down.
Somebody tell me, please.
Negative 1.9369.
0.9 Wait, that for the last one?
That was for B.
Times 10 to the
Negative 8.
negative 18.
And you guys get this guy? It's good you guys doing this really quickly. It's good. Because this is a big chunk of your test. Believe it or not.
Really?
Yes.
Are these multiple choice ones?
No, this is basically a page problem. Yeah.
Like this will be our page work, and then everything else is like multiple choice.
No, this is not the only problem. This is definitely not the only problem that requires calculation. You guys are fine. If you guys can bullet through this really quickly, this page should be a breeze for you. Alright? And
Just
I think
unsure.
majority of you guys have finished. Can someone tell
I
me?
can't remember what the equation is for this.
Siri kind of said it. That's okay.
Oh.
Alright, can someone tell me the, yes. You want to redeem yourself? Reduction, yes.
2.923 times 10 to the 15.
And what is your units?
Hertz.
Units.
Hertz.
Yes.
All in over seconds.
Yeah, either or. You can write the either or. Alright, so how did you come up with that value?
You just divide E by 8.
So what is the original equation that you used?
E equals H.
Yep. And so you change that into what?
Well, it's E equals HV, and then H equals E over V, or E over H.
Yeah. Cool. So basically plug and chug, 1.937 or 6, whatever you guys saw. Multiply 10 to the negative 18 over, this helps a lot actually. 6.626 times
Isn't it H nu? E equals H. It's H.
shifts or thing.
Dang, now there.
My bad, thank you. 34 joules per second.
What's that called? Me?
Yeah, yes.
It's like a V with a little V. Like a V.
Yeah.
You can just write it.
You can just write the that's completely fine. Alright. If you guys did not know that mu was frequency, I should highly suggest you guys memorizing that, because that's not going to be given to you guys on the test. Variable, like, notes on it, I guess, like telling you what the key is. It's not gonna tell you.
Not velocity.
It is not.
If it's like a V,
Yeah, it's free.
It doesn't. It's kind of like a V with a little curly-ish.
It's kind of like,
Yeah, it's like.
here you go. I tried to draw it, but it
It's
doesn't
just
really
like-
it's not for
Oh, Jesus Christ.
Yeah.
This thing's terrible.
it.
It's kind of like that. It's like a V with a little
Okay.
new. It's frequency, not speed.
I think it helps if you go sideways first, like these, and then
Oh, like this?
if you like that.
Yeah. Something like that.
So basically, don't spend all your time drawing these. Alright?
You can just write D. It really doesn't
Show a
matter.
bunch of teeth. Because you will not get points for being able to draw that very, very well.
But you will get points for noticing that it is frequency. And the higher the frequency, the what the energy?
Higher the energy?
Hell yeah.
It's valid
Or-
I guess.
Or,
You got this. Exam tomorrow too, which I'm going to study after this.
alright, so these are the specific units that you guys can use. Either one of these are acceptable. It's either this guy, hertz, 1/2, or seconds to the -1 power. Alright, you can write either of those units. Does not matter. Any questions about this? Any questions? No? Awesome. Should be pretty like, damn. And you guys guessed it, we got a D.
Hey.
And this is, I think it's the last one. Yes, it should be the last one. Okay. Tricky. All right, make sure you guys write this down because I'm pretty sure someone is messaging over the collaborator right now. Definitely is. Oh, sweet, they just joined. Awesome. Oops.
Wavelength formula.
Lambda. It's lambda. E equals HC over lambda.
Oh my gosh, this popping noise is gonna drive me crazy. It's people joining over online, which is
That Arizona must be good.
what?
I said that Arizona must be good.
Arizona.
The drink.
Why?
I don't.
Because it sounds like they're sucking on a bottle, like Snapple or
Oh my
something.
god. Anyways, did anybody figure this out yet?
No, I don't know what the you.
Isn't it?
Hold on. We got someone new that wants to answer. All right, let's say what is it?
102.6 nanometers.
Say it again.
102.6 nanometers or meters?
You said wait, 102.
0.6.
102.6 times what?
Like, well, if you have it in meters, it's the 10 to the -7. But if you have nanometers.
So you said 102.6.
Nanometers and then meters.
Okay,
1.026.
Yes. Okay.
Is the answer.
That freaked me out. Yes, that's right. All right. So what is the formula that you used?
C equals wavelength times frequency.
I'll say it.
See.
Yeah, what he said.
Okay, that's fine. Yeah.
And then so you just plugged, you did 2.998 times 10 to the 8 meters per second over the frequency you calculated above.
Yes. That's good. Yeah. So it's like 2.9. Okay, this is like honestly like ridiculous amount of sig figs. For like it's basically very close to it. 2.923 times 10 to the 15th. And one big thing is the fact that your answer that you are given.
It's always in. This is in meters though. With I heard it's in nanometers.
Yes. This is in meters. All right. Everybody understand that? Because speed of light, the units is meters per second. It's not nanometers per second. Otherwise, that'd be ridiculously fast. Actually, no, that should be slower. That'd be slower. Just kidding. That'd be actually a lot slower. So what is the conversion factor between meters and nanometers?
10 to the negative 9 meters equals 1 nanometer.
All right. So basically, the answer, because it says in nanometers, it's going to be 102.6 nanometers. That's your answer. 16668. You guys just finished 14 points of the whole entire exam. Yes. Oh, boo.
Let's work on 100.
All right. So before, oh wait. So did everybody write that down? Yes. So maybe. If not, copy from here. Any questions about that? The whole entire problem should be pretty self-explanatory. Just use the formula, plug and chug, use the values from before, solve for your unknown. Okay. All right. So we're going to go into something a little bit completely different from that. Everybody's favorite quantum numbers. Okay. Quantum numbers. All right. So he's going to give you something along the lines like this. NO, ML, MS, orbital name.
Yeah, the echo.
So basically, you just have to fill out the rest of the table. Okay, so you have to figure out what the orbital name is off of those quantum numbers. All right. For the people that just came in, there's a sign-up sheet. I don't know where it is right now, but if you guys have it, pass to the people that have not signed it yet. Oh, front row has not gotten the sign-up sheet. Raise your hand if you have not signed up. Or is it, okay. Oh, okay.
Maybe we should just pass it around.
So, where is it? Oh, okay. Boo, of course. What's up?
Because some of them just seem right to me, especially number 1, because you have L equals 2.
Okay, so then what would you write for the orbital name?
Does not exist.
There you go.
Fictional.
Number 1 doesn't exist.
I don't know. We will find out. This is why I don't like people just randomly asking questions about whether or not the answer is right. All right. All right. Any thoughts about the first one?
D&E.
What's up?
Does not exist.
There you go. I was like, wait, that's another one? All right, good. The first one, D&E, does not exist. Why does it not exist? Can someone else besides the first row tell me why it does not exist?
Come on.
So,
So L is n minus 1. Subtract 1. And value of 0 and 17.
yeah, that's a good way of thinking about it. Yeah. So, can someone else see it a different way? Yeah.
The first orbital is a sphere, so there's only one orientation you can really get.
There you go. So that's a really good point. So basically, your L value has to be n minus 1. You guys remember that formula?
Yep.
All right. So if your L value is greater than n, it's not possible. All right. So that's why it does not exist. All right. Move to the second one. Can someone from the third row tell me what the answer to that one is? Waiting for someone from the third row. It's okay if you guys are wrong. Okay, what's up?
3D.
Nice. Why how'd you get 3D?
Over the third and L starts at 0, S, so and then it goes S, P, G is 2.
All right. Does that make sense to you guys? She basically just said like the orbital 0 is S, 1 is P, 2 is D. Yes? Memorize that.
And
Good.
why does D have 5
So-
orbitals again? It just does.
M of L.
No, another way that you can remember is like how we have D here. Your L value is 2. So that means that your ML value can be anywhere between -2 and 2. So -2, -1, 0, 1, and 2. 5 orbitals. So that's another way you can remember D has 5 orbitals.
Sweet. Someone from the fourth row, the back row, tell me what the answer to the third one is. Someone from the way back. It's okay if you are wrong. I'd rather have you guys get it wrong now than actually on the test. And I'm pretty sure you would hope the same too. What's up? 2P. So he said it was 2P. Who agrees? Raise your hand if
It
you.
doesn't exist.
Okay, he caught himself. Awesome. It does not exist. All right, now why does it not exist? Can someone explain to me why it does not exist? What's up?
Oh, sorry.
Exactly. So basically, how I would check it is basically you start from N and then check L. Is L less than N?
Yeah.
Yes, so it checks off. Now ML has to be, what is it? Has to be
-1, 0.
plus or minus L essentially. Right? Exactly what you said. You said the values could be -1, 0, or 1.
Yeah.
Right? But this is 2. So automatically, that's the reason why it's not right. And then for the first one, that's the reason why it's not right. All right. All right. So anybody can answer this one. What is the answer to the fourth one? Very last one. I'm hearing whispers of 4. Okay. Sure. 4F. Nice. Yes, the answer is 4F. All right. Does that make sense as to why it is 4F? Can someone explain to me really, really quick? Oh, boo. Yeah, pretty self-explanatory. Awesome. Nice. All right. Does anybody have questions on this? This is definitely going to be a chart that you guys are going to see. It might be various numbers, different stuff. He might give you like an MS value of 1. And you guys know that's wrong exactly because the MS can only be positive or negative 1/2. Right? You guys will memorize that. All right. Okay, so before I start this next problem, can someone tell me what is the difference between diamagnetic and paramagnetic? Sure.
Okay, so diamagnetic means that, because when you write one thing about that, when you write out the orbital diagram,
Yep.
like the last shell is completely filled,
Mm-hmm.
but then in paramagnetic, there's one of them that's filled, but another one's not.
Exactly.
There's at least one.
So basically, you need to have all paired electrons in order for it to be diamagnetic. And then you just need to have one of those electrons. Like, you know how he draws like a box for like the orbital, and he has one going like that, one going like that, right?
Excuse me.
This, if you just have one left, is going to be paramagnetic, and this is diamagnetic. Cool? That's like a little key that can help you guys out. So, I'm going to have you guys do,
Configuration.
If you guys don't have a periodic table, try to just borrow from someone or look it up on your phone. Alright, so what you guys are going to do here, you guys are going to do the electron configuration. I'll just write electron conflict. And you guys are going to state next to it, which I'll also divide it, the number or unpaired electrons. Going down. I shall erase this. That. And you guys gonna tell me whether or not, oh my god, diamagnetic or paramagnetic.
The number of unpaired electrons?
Yes.
Okay.
Oh my
I do that to help myself out because I can't draw straight up. I need to go to over that first, and then I do the.
Do we have to draw the arrows for this, or is this just the right?
You could honestly do it either way. I mean, both of them you could use. So.
Oh.
Yeah.
Will he say if we should do like the short, like with the noble gas?
Yeah, no, you definitely can use the noble gas notation because it's essentially the same thing. If you want to go the long route, write everything out, you can, but save yourself time, do the noble gas.
Actually, it might be.
Oh,
If you guys have any specific questions, we can like roam around and help you guys out. So.
okay, so. Okay. So, I know manganese, right? Is it one of those transition metals which has one of those tricky electric configurations? Is it one of those? Is it one of those? So the exceptions are CR. Oh, exceptions are CD and CR, right? Are those the only ones? Same.
That's just for L, I thought you were asking.
Those are the exceptions.
I don't understand that either.
Oh, one, two, got you. Thanks.
Which ones are the exceptions? If you guys look at your table, CU and CR, and then right below those two, all four of those are exceptions. If you want to go even further, you can, but most likely not going to give you guys that.
What do you want for the second count?
The number of unpaired electrons. Unpaired electrons.
How do we know if we can do the like noble gas?
You can do it honestly whatever.
I don't know how to determine number of unpaired electrons. One unpaired electron.
No, you don't have to do that. All right. Anybody got an answer for the first one? Yeah. What's up?
1S2, 2S2, 2P5.
Yes. All right. Say that again. Sorry.
1S2, 2S2, 2P5.
All right. Sweet. Awesome. And how many unpaired electrons are there?
There's 5 unpaired.
Are you sure?
Oh, sorry, 1.
Oh, it's okay. There's one. Yes. Awesome. Nice. All right. Is it paramagnetic or diamagnetic?
I make it.
Para.
Yes. Why is it paramagnetic?
Because it has one. If it has an unpaired electron, then it is paramagnetic.
Exactly. So basically, these answers are dictated by these answers. So if there's any value as an unpaired electron, it's automatically going to be paramagnetic. All right. Cool. All right. Anybody got the second one?
I'm waiting for the
I got 1S2. Oh shoot, you got the long now.
All right. Go for it.
Sorry.
Go for it.
1S2, 2S2.
Oh, we're writing it all out.
Sorry,
I say we do noble gas configurations.
Yeah.
Who seconds that?
Okay, yes, thank you. That makes my life so much easier. Alright, so what is it?
Okay. Argon.
So 2 plus would be
Argon.
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 Alright.
4s to 3
Jesus. Alright, how many unpaired electrons are there?
5.
Yes. Why are there 5? Some of you guys might not guess that. Why is there 5?
Because the D subshell has 10 states.
Yes.
So it goes up to 5 first.
So there are 5 orbitals, meaning that there are 10 electrons that can be placed in there. Now, can someone tell me what are the rules that apply for that? Well, what? Why is it 5? Why is it 5 unpaired electrons versus just 1 unpaired electron?
Is it the Hund's rule?
Is it Hund's rule?
Yeah, I believe so.
Confirming with no.
Yeah, it is.
Sure.
Yes. Okay, we got a yes confirmation. Awesome. So let me go up a little bit. So basically, the D, you're gonna have 1, 2, 3, 4, 5. All right. So basically, what they're saying is okay, cool. Yes, it's Hund's. Hund's. And what does Hund's rule state?
The rule states, the simplified version, you occupy each orbital individually before you start adding the second electron to each orbital.
And just so you guys know, this might be a multiple choice question. Okay, it might be like, so what rule states that occupying each orbital until you start occupying the rest? So basically, because it's 3d5, you're going to draw it as 1, 2, 3, 4, 5. Okay, it wants to fill all of those.
Rather than 1, 2, 3, 4, 5.
Yeah.
Which would only leave 1 unpaired, but that's not what we want.
So yeah, exactly. We do not want this.
Basically, it's more stable. Electrons don't like to be close to each other. They like to have their own space. So when you push them close to each other, they're not too happy.
Remember his whole connection with like the, who here has a sibling, and then somebody yelled out, oh, I have a dog, does that count as a sibling? That type of thing. So it's kind of like, think about that lecture, and then I was like, really interested.
Because you're really dysfunctional.
Is there a math class that he does this shit all the time? He's awesome.
Alright, so is that paramagnetic or diamagnetic? Paramagnetic, awesome. Alright, next one. Someone say this one. Cool, go for it.
Argon, 3d5.
Awesome. How many unpaired electrons?
5.
Cool. Paramagnetic or diamagnetic? Para. Cool.
Why do we not have the 4s?
Because it's an ion.
Yes.
Subtract 2 electrons to take it from the highest electronic energy state, instead of the core, not 3. So you take it from the 4s orbital instead of the 3.
The S is in the
So basically what they're saying is like, if you want to show like energy levels, this would be the 4s.
Like you see how
So basically, without the ion, you would have this, right? Or you want to get rid of
But they take rather than taking 3 electrons
of that. Alright, we're going to do the last one. So, then we get the last one. Last one's a little bit trickier. Awesome. Oh, wait. Sorry, over it?
Sure.
What is it?
Well, argon, it'd be argon 4s or 4s2,
Okay.
and then 3d9.
Close. It's not exactly that. Can someone explain to me why it's not that?
So you use the exception, so it has to be 4s1,
Right.
3d10.
Yes, good. Does that make sense as to why it is that?
Yeah.
I want to make sure everybody understands. Close.
Can you explain it?
Yes. Okay, so for us, you got that, and then you got your D's 1, 2, 3, 4, 5. Alright? So typically one would think that you would draw it like this, right? 1, 2, and then 3D9, so it'd be like 1, 2, 3, 4, 6, 7, 8, 9, right? Well, with the whole concept of like this one before, when we did the ion, we wanted to get rid of those 2 electrons because those are from the highest state, right? From the higher state. So basically for this one, this electron right here, because it's in a higher state, but there's still one space to be occupied, this one electron jumps over here, so is that.
There's a pretty big driving force to fill up all of those d orbitals, as opposed to having like really close to 10 and then you're missing one. So it's a driving force. You want to occupy all of your d orbitals if you're pretty close to.
Yeah. So that's why, yeah, what's up?
Is that the same thing for everything in the column?
Essentially, right?
Yeah, transition metals, they're all kind of dirt, so kind of do the same thing.
Yes. What is the other exception? Can someone else tell me the other exception that is not within the column with copper? Chromium. Chromium is the other exception. Why is chromium the other exception?
Because it wants to be helpful.
That's 4 up there.
What is chromium? Chromium is what's the electric configuration of chromium?
It's the same thing, but it's 5 instead of 10.
Yeah. So it's 4s. Yeah, 4s1 and then 3d. Yeah. Same idea, same principle. You have that 1, 2, 3, 4, 5, 4, 5. Typically, you're gonna have this 1, 2, 3, 4. Same idea. You have this guy left, and this also jumps here, so you get that. All right.
It increases going this way.
Yeah.
Up and down, there's no.
Yeah. So.
Do silver and gold
That's
do the same
electronegativity.
thing?
Yeah. Hold on. What's up? Sorry, I can't hear you.
Do silver and gold do the same thing because they also have 9 electrons in the d orbitals?
Let me see if I can.
Yes.
This is.
Yes. Yes. That's true. Exactly. So everything in the column underneath chromium and copper
So these like
basically have all these exceptions.
These all have the same.
Can you explain counting valence electrons in
Yeah.
transition metals?
Counting valence electrons in transition metals.
Yeah.
Yeah. Up and down.
Like I was looking at the chart.
So like, do you count all the D and the S ones?
They were the ones over here.
Or like how?
Oh, they just like tell you.
Yeah.
And then, like, it was all over. Like there were white ones over
Okay.
here.
So when you have, so transition levels, they're going to have electrons that are occupied in, okay. So the way you normally think about it with like carbon and nitrogen, all those smaller ones, those guys aren't transition metals, right? Those are like 2s2, 2p, or 3p, whatever, right? So the moment that we get into the 4s, that's when we introduce our 3d orbital, right? So what we're focused on is the outer orbitals. So with the smaller ones, the outer orbitals are 3p, 3s, 2s, 2p, all of that good stuff. But with larger atoms, like transition metals, the outer electron energy levels are being occupied by the 4s electrons, by the 3d electrons, by the whatever f electrons, right? So when we see something that's like in the 4th column and below, we're going to notice, and it's the periodic table it can kind of like guide you in that sense, where it's in that row where you have the D column in there. So that can kind of be another clue. So it's like it goes like 4s, 3d, 3p. That's like energy kind of. Like 4s, 4 is n equals 4 for that case, the highest electronic state, right? And then 3d, I mean, granted it's d, so it's above like p and s, but it's still n equals 3 with 3d. So that's why it's just below. But 4s only has 2 electrons, so sometimes those are taken away, sometimes they're shifted. So then we look at the one right below it, which with transition metals is going to be in your 3d column. Or 4d, if you're n equals 5. Make sense?
So you could have like 10?
Total in the D orbitals?
Like valence?
Yes.
Like could you have like 10 valence electrons in it?
Wait, what is yeah.
What just happened?
Sulfur can have a big chunk of electrons.
To answer your question, really don't have to worry about it.
Okay, because he put it on the quiz and he never told us. So
Yeah.
I don't know.
Okay.
Is electron affinity going to be on the test?
Oh!
I'll be trying.
Oh wow, you guys are asking really specifics. Okay, so Yeah, I might as well just go into that actually because it's gonna help you guys out, figure everything else out. Periodic trends. Do you guys remember what the trends were?
Yeah.
Based off of atomic radius, electronegativity, ionization energy.
Yeah.
Yeah.
I'm just gonna draw it really quick so you guys understand. So we got yeah, and then we're gonna have like that other stuff that. Okay, so what is the atomic radius trend? Either one.
Okay, going here, the atomic radius
Going
decreases.
where?
Going across from left to right, it decreases.
Okay.
And then going from top to bottom, it increases.
And then
It increases from top to bottom.
yes. Increases atomic.
Memorize it.
Yeah,
Where so?
because on this side of the periodic table, the Z effective is higher, which means that the nucleus is going to draw the electrons towards the center a lot more, which decreases the radius, right?
What is the effective?
Like,
It's just the charge of the nucleus, basically. The more protons, as you go farther down here, you're increasing your number of protons by 1, 1, 1, 1, right?
Right.
And protons, as you're increasing the number of protons in the nucleus, that's more power, more is the effective charge. It's going to take those electrons closer, right? Just because there's more positive charge electron. So as it pulls it closer, shorter radius. Yeah.
Does that make sense?
Yeah.
Yes.
So essentially, as you're increasing the amount of protons, it's basically just
There is more shielding, but protons. Yeah.
all right. So can some of you guys explain why the atomic radius increases going down?
The end value.
More shells.
Exactly. Yep. As you increase shells, it's just going to get bigger, right? So that's one way to think about it. Now, using the atomic radius to help explain why there's ionization energy and electronegativity, what are the trends of those two? That's us.
From left to right, electronegativity increases, and from bottom to top, it increases as well.
And this is for what?
Electronegativity.
They draw it as like a diagonal from bottom left to the top right.
You can do that.
You can do that as well. Yeah, it's completely fine.
It's like if you're.
Oh, yeah, my bad, yeah. Increase. What about, oh wait, we have to explain it. What is electronegativity defined as actually? That should definitely help out.
The ability to attract the electrons.
Ability to attract.
how much they want another electron.
Yeah, it's an affinity for electrons.
Okay. What's the difference between electron affinity and electronegativity? What is the difference?
Can tell you it's not going to be a multiple choice question.
He said we weren't supposed to worry about electron affinity, that he accidentally put that into the homework assignment, and that we're not going to.
That answers your question.
So the answer is you don't need to know it.
Don't need to know it. All right.
You don't need to know electronegativity.
I think.
No, you do need to know
Affinity.
electronegativity.
Electron.
All right, really quickly,
Affinity.
what is ionization energy? What's the trend?
Higher.
Increases
The
the
ion.
same way as.
Yes, exactly. So it is the exact same way as electronegativity. That's increasing in ion energy.
Because ionization energy is the energy required to remove what?
An electron from the
From the atom. So the closer that electron is to the nucleus,
the higher the ionization energy.
yeah, there's more of a force, right? It's harder to pull away. It's more attractive to that nucleus.
Right.
Okay.
Cool. Anybody have questions about this? Otherwise, I'm just going to keep moving on.
Would you have to explain on the test and like why everything happens?
You don't need to. I'm not 100% sure if you need to explain it, but it's good to know like these trends because they'll help you a lot. Hint, hint, it's going to help you guys a lot with multiple choice questions. Because
If you know the concept behind it, then you're not just sitting there kidding yourself, and you're like, but if you remember the concept behind it, you can captured out, and then there it's a couple seconds.
Yeah. So that might be a possible multiple choice question. It's going to give you a series of elements, and he's going to ask, tell me from largest to smallest of atomic radius. And that's like A, B, C, or D. They're all going to be the same elements, just in different orders. Okay. So you guys have to basically solve it that way. Another question. This one's, hopefully you guys just watch it. What? Oh dear Lord. If there's any numbers you guys can't read, I apologize. You guys should deal with it.
What? I don't know how. I don't know how the answer is found for this.
6 to 7, like it jumps a lot. So that means that you're going into the initial.
How's the answer? Third period. Oh,
All right. So since there's a lot of talking now,
5, 6, 7, 8.
can someone define for me again what is ionization energy?
The amount of energy needed to remove an electron.
So number 5.
Yes. Good. So the amount of energy to remove an electron from an atom at its stress state, right? So to dissect this answer, did anybody come up with an answer and would like to share it? Sulfur. Cool. The answer is sulfur. All right. So the answer is sulfur. Why is it sulfur?
Because it's the largest jump between 6 and 7. So it's hardest to remove the 7th electron. So therefore you subtract 1 and you count 6 valence electrons.
There you go. Okay. Cool. So actually, I taught you that there. So basically, to dissect these problems, I just look for the biggest jump between the numbers, right? So I said that the biggest jump is between the 6th and the 7th ionization energies, right? So basically what you would do from here is you just count back. It's going to be 1, 2, 3, 4, 5, 6, right? So then you got 6, which means what?
6 valence electrons.
Exactly. So 6 valence electrons are being removed.
In a group 6.
Right? Exactly. So you know it's going to be group 6, and it gives you guys a period. So basically just use a grid to be able to figure out where it intersects, and that is your answer. That's going to be sulfur. If you guys look at a periodic table, you guys go over to you guys go over from the left-hand side to the right-hand side and count 1, 2, 3, 4, 5, 6. Right? Nope, that's not right. That's definitely not right. From the third period, yeah. You count over 6. 1, 2, 3, 4, 5, 6. You guys should end up with sulfur. All right. So yeah, there's that. How much time we have left? We have 3 minutes. Okay. This one's pretty simple. This one actually trips up everyone. This actually tripped me up on the exam because I had absolutely no idea what he's asking for. All right, really short and quick. Sketch. All 2p orbitals. And he wants you to show the sign of a function and label them. We got this whole entire problem wrong. Yeah. Sketch items. The problem is actually a lot simpler than it actually states, just so you guys know.
Showing signs of wave function.
Yes. It's like, what? Right? It's like, what? So when I did this problem, I was just like, wait, what is he asking for? I just drew random stuff. Does anybody...
Oh, is it X, Y, Z?
There you go. Anybody got it? Anybody got it? What's up? What's up?
Wait, do you just do X, Y? Do you want to go?
Doesn't matter, you go for it. Someone's
I
gonna
have
have
a
to.
question. So, do you just do X, Y, and Z, like the dumbbell, and then just put plus and minus?
Exactly.
Yeah.
That's it?
Yep, that's basically it. So, for this question, there are multiple ways to actually answer it. There's actually not multiple, it's only two. So basically, you can either show this. All right. So this is going to be your X, Y, and your Z. Understand it's like a three-dimensional type of figure on a two-dimensional surface. So you can draw it this way. You guys remember that the p orbitals always showed you guys like s orbitals are a sphere, p orbitals are like dumbbells, right? Right. So basically, to answer this problem, like get a whole points on it, it's actually about 6 points, just so you guys know. Basically, you would do this. That plus minus. This is going to represent the px. Bam. Plus minus. This is going to be py. And all these dumbbells are according to that. All right. Just make sure you guys memorize that. And he actually really likes if you guys show this. If you guys show this brownie points, to do the z, he likes to do perspective stuff. So he likes to make it small back here and then large in front.
All perspectives.
All perspectives. So like plus, minus, and this is p, z. Right. And if you guys want to get super fancy with it. If you guys really want to get super fancy with this whole entire thing, you guys can draw it like this.
Does it matter which side the plus and minus are?
No. I don't think so. Yeah. So
It's just a He's ready.
But in this case, you guys still have to show plus and minuses.
What I did was that.
He shaded it in.
Yeah, I shaded it.
Yeah, you can do shading in as well. Either one is fine. Any questions on this? This one should be more of like a see this question, bam, this is what I draw. You guys should just know what the orbitals look like.
If you haven't signed the sign-in sheet, it's up front here.
Yes. It'll help them visualize like what you're drawing. So it'll only help. If you don't draw it, that's fine. As long as you label, as long as you have these guys right here, it should get
Okay, so did it specify like 2p or just to sketch all p orbitals?
Yeah, I mean the same
So
thing.
then would you like the two?
You guys can, yeah, that's fine.
Actually,
So it's these concepts that'll have
Is thermal commission going to be on the test? Yeah, we did.
I don't think it's
No, yeah, it's not.
alright, so those are like.
No, he said 7A wasn't. I thought.
7, 8 is.
What? And like it was like the PX with a ring around it.
7, 8, 9. Before I go to bed, I'm gonna watch all those videos.
it's just depending on the weight where they fall more, but
Formal charge. Yeah, that's what you like. Chapter 7, chapter 8. Part of that.
Yeah. Don't write that out. Okay, I got it right. I'm gonna draw that.
Yeah.
So it's like it's formal charge, visible.
There's M2 and it's ultraviolet, and then if it's infrared,
You gotta, yeah, it's only gonna be like, I mean, it's a possibility. You told us it's a possibility, so I had a successful study.
Is like
and then I go back to
So,
yeah.
and 2, and so they're concentric circles. Right?
Yeah.
Kind of
I would cover that.
Bigger by smaller quantity, so it's like
Yeah.
n equals 1, 2.
Yeah.
Okay. So then that way we have
Smaller and smaller.
yeah.
So the idea behind that is that change the difference in energy between n equals 5 and n equals 4 is much smaller than
I'm pretty sure.
5 and how but really if you get so far away, so small change, small.
I mean, that must be wrong on the no.
That means long way or long lambda. So
Yeah, 2.
So if we're like starting with 4,
have 16
what if you have 3? What if it was 5? You don't know if
It depends. Are you thinking about it
it's.
as?
That's a.
if it's the case,
Actually, no.
I think they need to tell you similar to your homework. They tell you it's a bracket or because what if they're problems like that where they say this is a blank
Oh, so
transition?
because of these 2 and you don't have them because they're 3
Yeah,
and
it's
not 4.
ambiguous as hell.
But if it was this one, then you had to say
I'm not looking at actually, you said
There's some things that are just like.
yeah, you did. You literally just mumbled. Yeah,
I realize that
you're on your phone and you don't pay attention. Exactly. This is why my goal is you have an phone. It's like you're so addicted. Yeah, that's why you just said yes. You don't even know.
Ultraviolet.
No, you weren't.
Higher energy than odds are to give off more energy than if it was visible in a case.
Like the
Like ultraviolet, it jumps from
okay, so basically you just that is
visible.
visible.
I'm not as much energy I give off a little bit.
You can
That's that's a way to consider.
You're gonna have. I mean, you know,
Again, so you're not sitting at the test.
you're gonna have.
I forgot.
Yeah.
Whether or not it's correct, like, you can kind of.
Ultraviolet says greater
So-
energy, therefore.
Why do I?
For that example, because that covers the
Yeah.
So what other pages?
I'm not sure.
Oh, do you think?
Yeah, I think I get these ones.
Typically, like,
And then,
you can remember.
how
Ask him that.
do you,
What do you think about the series? Just
how many pieces
Yeah.
So like if it's ultraviolet, ultraviolet
the
will
wavelength?
visible light
visible.
Well,
for
if you
infrared,
don't
we'll have
know
to
how,
tell you.
I know that you don't know how to
You can just kind of remember which one's greater energy and which one's less energy. You can just remember this.
Will we get our calculator?
I don't think you have to really.
Convert what? The thing?
Calculator?
You might need to know
Cool, okay, cool.
values.
There you go.
It's from like the 10 to the 9th, it's like they put the denominator in there.
Okay, cool.
Where it's like,
You just memorize this nano 9, nano 9, nano 9.
How do you
Memorize that. Good.
Nano 9, yeah.
Nano 9.
Positive?
How much will it structure?
You know that nanometers are a lot smaller than meters, right?
Yeah, it wasn't.
So,
Also, it would make sense if it's positive, because it'd be a lot negative.
well, like 1 meter. Well, it's 1 meter is equal to
the thing that they. I was just checking.
Wait,
10
you
to
told
the
me.
9 nanos.
Reject my jump drive. Close all the files that are rejected.
Okay.
Yes.
Like the
Just
and
memorize this one. Memorize that.
Well, if you find wavelengths, how do you know if it's?
Like,
You mean what I meant like they were equal? Okay. Yeah.
to be honest,
I'll sleep with that.
I don't think you're using to memorize that specific.
What about your
does give you
face?
something
I
like.
don't know.
It's
You
the way
a gray line.
You can memorize the two
Where?
bounds of visible.
No, it's
Yes.
just well,
Visible is like
all the fun.
300 nanometers.
What?
400 nanometers.
It was
Anything
Is there a gray line on my head?
greater
You're
radius.
supposed to go
Like right on my forehead.
Typically,
Oh,
transitions are correct.
yeah.
So if it's below you,
Nerd.
Yeah,
It's like
above
line.
you,
It's like she was like trying to wake up. Like, no, I got something off with the floor.
Oh, really?
And so
Well,
I think
I would.
Goes here, it's greater wavelength or greater energy.
The trends on
Yeah.
this, like, yes. I mean, that'll help you. It'll help
Oh
you.
yeah,
I don't
on there,
think
no,
it's
it's
easy
for
to question, but
No,
it's
Charlie,
very
no.
conceptually and like you.
Okay, what else did we do? We had.
Make sure you also memorize, just know how to do formula charts and stuff like that.
2 weeks ago, we had
I did
a
cover
sleepover
today,
and
which
initiation.
I should
Stick notes?
We're having time on Friday. I could do an example.
No, those are.
I'm sure I'll get people complaining when they come to my table.
Formal charge. You guys need to know formal charge.
What is that? Oh no, that was something we were having trouble
You guys learned it? Or like basically last lecture?
It's like you take the number of valence electrons it has, subtract it from the number of lone electrons minus the number of bonds.
Remember when we had the drawings and we had to put the
Oh,
positive
yeah.
negative on the drawing? And we kept getting them wrong and then we read it again and we're like, oh, it's because we have to put the charge. Yeah. That's what it is.
There you go.
How
Yeah.
much Lewis structures are there?
Lewis structures, yes, but it's not going to be a lot. It's very good.
Are they like easy ones?
Yeah, so
Yeah.
easy. Like one of the examples that he gave me actually, he gave me one that was actually draw
Just talk to my boss.
from
What's the
algebra.
number?
Yeah. There you go.
You have to draw from algebra. Right? So basically, what you would do, because this is again chemistry, yes, but basically start at the center with carbon, right? And then what he wants you to do, like to show your work, he wants you to be like, okay, so I have hydrogen, oxygen. First, I just draw single bonds towards everything.
Yeah.
And the oxygen is going to have like what 1, 2, 3, 4, 5, 6. But if you look at this, carbon doesn't fulfill the octet rule. So basically, these guys are gone, and it makes it a double bond.
When you find out the technique,
So, yeah.
what's that?
There won't be one like the
I don't have
SO4 with all the oxides filled.
Sulfur is weird. So sulfur is
Yeah.
right below oxygen. So the fact that the N is one
I
greater
don't
than
have
sulfur
170.
fricks everything up. It can make a shit
Yeah,
ton.
I'm not doing.
And also,
I literally don't.
Okay, sinus.
That's why I like with sulfuric acid.
I'm gonna check some.
SO4. That's why it's bonds into 4 oxygens. 2 of them are double bonds. 2 of them are single bonds. So it makes 6 bonds total. And that's just because it's one below oxygen, higher.
We don't need to know cis and trans isomers, do we?
this is another example that you guys might get. It's a noble gas. What do you do with noble gases?
They have many bonds.
They could have more bonds, but because it's only 4 fluorines, you're basically going to draw like this. Shoot, what is this?
It has like 4 extra electrons out there.
Yeah, it should.
If we do lines instead of dots,
Right.
is that okay?
What's up?
If we do lines, like lines for 2 electrons.
No, you can't do like if it's like you're drawing this, you can't. Sorry, you can't do that. Is that what you're?
Yeah.
Yeah, I get it.
Okay.
He's not gonna like that.
Okay.
So like
Does
for
D
bond.
grade the test or do the A's?
I don't remember, to be honest. Most likely TAs because there's a lot of you guys. So is TAs or?
He might actually grade it.
I think
All of them?
hey,
Zion can be
Why
a
not?
machine.
my EC professor grades
They can-
all
they can do
120
it.
of our papers for the
I don't know
test.
how they do it.
So, I mean, regardless, it doesn't really matter.
Okay.
Who's grading it doesn't matter. As long as you guys get the right answers, anybody who grades
I
it is
would
going to
look
give you
at the teacher
100%.
grade it because he sees you in class. That is, if you go to class.
He sees me.
He won't in class. You're in the back though, so he probably doesn't see you at all. He definitely
This is one session. Just for the whole entire
That's like the 3 people.
Yeah.
This one?
Oh, I have to enter all of these in.
Because.
29.
can explain slowly everything except for this part. Knowing the end right here if you want. You can read my notes.
Oh, okay. So based on
Yeah, no, but you fell asleep during one of the lectures. I was back in my bed.
Right?
Actually, I might gotta take a note of that one. I might have been on my computer.
Most likely. You have that out on the model too.
Oh, wait, yes, I do. Here we go.
Oh yeah, that's nice and small and then.
And I have
the presentation. I just want to show you.
12 to 2.
Yeah, exactly.
Oh,
wait, I need to stop this, because. Arc Scholar. Shoot. I just kept listening so I could say this. Dang it.
Yeah, that one too. Literally everyone got it wrong because he never explained it.
Impossible. Wait, why is it?
Why is it I
wrong?
know.
Which one?
Everyone got it wrong, and I'm really mad.
That should be impossible because you'd want 1, 2, 3, 4.
It's like it's possible. It can still happen.
Because it's violating hundreds.
I was shaking with my brain.
Oh no! Oh my god!
What is this? I asked you about it.
Ashamed of my grade.
You said it's possible. You said this is possible.
So not that.
Wait,
What
rule is it breaking?
Starting here.
Yeah.
Wait.
No, he explained it to me. He said it can still happen, even though it violates the 100 rule. It can still happen.
Really?
Yeah, I know. I literally started wrong. So.
Chemistry has a lot of exceptions. That's my.
But like,
That's what I would have stopped that question.
everyone got it wrong.